Oxidation reduction reactions, or redox reactions, are just plain awesome. I mean, some of the most exciting reactions that we know of are redox reactions. Think fireworks, or explosions, or even just lighting a backyard fire pit. Your body runs on redox reactions to take the food that you eat and turn it into energy. Think about how many things you have with you right now that run on batteries. Might be your phone, might be your calculator that you carry around, it might be your laptop, you might have your chess clock with you, because why not? All of these things run on batteries, and a battery is a device that uses a redox reaction to produce an electric current that runs your devices. A redox reaction involves an exchange of electrons from one chemical species to another chemical species. Oxidation itself is defined as the loss of electrons. So in any transaction, there's something that is giving electrons, something that is taking electrons. The one that's losing electrons is said to be getting oxidized. And the word oxidation comes from the fact that early chemists noticed that when things combined with oxygen, they got a little more positive, and that means they had lost electrons. Reduction, on the other hand, is the term we have for the gain of electrons. Yes, I know it's confusing, but yeah, it's gain of electrons. And the word reduction actually comes from not the fact that we're gaining electrons, but because when something gains negative electrons, its charge goes down. I have here some silver nitrate solution, about 0.1 moles per liter. And if you've been paying attention in chemistry class, you know that silver nitrate is soluble, as all nitrates are soluble. And that silver in solution has a +1 charge. I also have a solution here of dextrose in some water. And dextrose is a simple sugar. It is also an aldehyde. And the business end of the aldehyde is the double bonded carbon on the end of the carbon chain. And that is where some oxidation is going to occur. What I'd like to do is do a reaction between dextrose, which will get oxidized, and silver, which I hope will get reduced. I'm gonna do it right here in this flask, and if all goes according to plan, we'll see something really cool in a couple minutes. First, I'm gonna add some dextrose to my big flask. Then I'm gonna add some silver nitrate to a smaller flask. That looks pretty good. Now over to the fume hood, where we're gonna add some concentrated ammonia. See a little bit of precipitate happening here. In case you're wondering what happened over there in the fume hood, the addition of a small amount of ammonia causes a precipitate to occur with the silver, but adding more ammonia causes the formation of a complex ion of diamine silver, and that is soluble, and so we have a solution of soluble silver again. And now I switched it to a bigger flask because I'm going to add some potassium hydroxide to my solution and check out that precipitate. And back to the fume hood for the addition of some more ammonium hydroxide to try to get that precipitate to redissolve. So now that our silver is soluble again, comes the moment of truth. And that's when I dump this into our big flask. See a color change there. We're gonna stopper it up. And now I just have to shake it for a few minutes and pray that it works. So check it out, it totally worked. The dextrose was oxidized, giving up some of its electrons, and those electrons were picked up by the silver ions, which became silver metal and started coating the inside of this flask. So now I have a giant 2-liter silver mirror flask. Is this not the coolest thing you've ever seen? So there you have it, oxidation and reduction. Good for fire, good for your body, good for batteries, and also just good for doing really cool stuff.